Hello and welcome to the MLOps Minute. So we've set up our Git, we've set up continuous integration, and now before we start coding, I'd like to take a moment to explain how the workflow of an AI project works. Here we go. So what happens is that in production today, we receive around 10,000 PDFs a day, and we're a team of 20 people who open these PDFs. On each PDF, there's only one image of a cat or dog or whatever per page, and they have to classify each page to tell whether there's a cat, a dog, or something else. Knowing that there are time constraints, i.e., by the end of the day, all 10,000 PDFs have to be processed, so there can be mistakes. And we're all human, so we can make mistakes, sleep badly, be lucky enough to have many children to help us stay awake at night. So our goal is to set up an API that automates these actions. We'll receive PDFs as input, extract the images present on each page so that we can feed them to an AI that can classify whether each page contains a cat, a dog, or something else. So that's the aim of the project. You should know that in artificial intelligence, one of the subsets you'll hear is machine learning, and a subset of machine learning is deep learning. And in our case, we're going to use deep learning in supervised mode. In other words, we're going to feed training code with data which will generate an AI. And this AI afterwards will not move in time. In unsupervised mode, the AI will constantly train itself. When you have data with a fairly finite number of inputs and outputs, which can be represented by an Excel or CSV file, in general, we're going to hear about structured data. And in this case, we'll generally implement machine learning algorithms. And for example, use libraries such as scikit-learn, which is a well-known library made by French people. When you have a very large number of inputs and outputs, we'll generally be talking about unstructured data, typically text, sound, images, or video. And in these cases, we'll generally be using real neural networks, i.e. deep learning algorithms. You'll probably hear of TensorFlow or PyTorch in general. These are the libraries most often used for this kind of use case. So to understand this type of project, you need to understand that there are three major paradigm shifts. So the first, what I'm telling you comes from François Chollet and his great book, Deep Learning with Python, where every page is a real goldmine. I really urge you to read it. So when we work with classical programming, we have rules, we're given rules. Rules, we have input data. We write our algorithm, some if, some else, which enable us to generate responses. That's what classic projects are all about. In machine learning, it's a bit different. As input, we'll have data and answers. This will enable a developer, a data scientist, to write algorithms to generate an AI. And this will enable us to generate the rules. And these rules are what we call AI. And technically, in computer science, we talk about models, AI models. In production, it works exactly the same way. In other words, we receive data. With classic code, it executes. We get the answer. With AI, it's the same. We have data. We have classic code, which will use an AI, a bit like a library, which will generate answers. Second paradigm shift is data. Historically, we used to talk about model-centric projects. In other words, when we were asked to carry out an IT project with AI, we weren't sure we had everything we needed, technically speaking, to produce AI that met our needs. Today, things are a little different. For most enterprise use cases, we know that we'll be able to create AI to meet needs. However, what makes the difference is data, because if you have good quality data, if you can remember the data and the answers. You can train your AI as well. For example, if you don't have data and answers that are only half right, your AI won't be able to do better than half. And that's really the heart of the matter. Data is gold, gold in a box. What I like to say is that pas de data equal, no AI. Third very important paradigm shift is that it's alive. It's not alive in the sense that an AI is alive like us. It's alive in the sense that data evolves. See this identity card? If an AI has been trained on the old ID card, it won't be able to read the new identity card. This means that businesses are going to change, and we need IT projects that are capable of retraining and learning new data updates so that projects can continue to function. We need to set up IT projects that can constantly retrain AIs to be able to adapt to changes. Take our cats and dogs and other classification projects. We need to start collecting data. It's a good thing that in production we receive 10,000 PDFs a day. What's more, the good thing is that we have answers, since we have annotators. Now we can start trying to train an AI. But on the other hand, when we do that, we may realize that because it's human, we have time constraints. Maybe we don't have enough good answers. In that case, we'll have to enter a labeling phase, i.e. annotate the data to increase data quality. We never talk about it when we talk about GPT cats, but that's the heart of the matter. It's the data. Let me give you a small example. Here, it's an annotation application. I've got an image. I'll have to say it's something else. Here's a cat. This is a dog. This is a cat. Here's other thing. That's a dog. There. It's not obvious, but it's a dog. The thing is, this is my passion. I love spending my day doing this. What happens is that it increases the quality of the data so that your AI tends towards a very good prediction rate. Once you've trained an AI, you can deploy it in production as an API. Once it's deployed in production, you can consume it via a consumer who will be able to call cats and dogs and send us PDFs to retrieve the prediction results. And here's something that's very important to put in place, what we call the feedback loop, because the data will evolve over time. For all we know, tomorrow we'll have photos of cats and dogs generated by AI, photos of cats and dogs, or drawings of cats and dogs, of cats and dogs. Our model hasn't been trained for this. It won't recognize them very well. And then by setting up the feedback loop, we set up a virtuous circle, which will enable us to constantly reconstitute data sets that will enable us to train the AIs. But we mustn't forget to always enter this labeling phase to control the data and ensure that it tends towards good data quality. It's important to understand that the labeling phase is virtually indispensable before any retraining or data change. So if you want to train an AI, imagine I've got 20,000 images. What's going to happen is that you need to take around, say, 13,000 images to train the AI. And internally, it needs to use around 4,000 images for validation. And these are the images that the algorithm will use to train itself. And in fact, once we've generated a model, these images are somewhat biased. Why? Because the model has learned from them. As a result, we need to set aside a set of tests to ensure that our AI hasn't memorized this data, and that our AI is capable of making predictions on data it has never seen before. And that's what we want. We want the AI to generalize on data it has never seen in production, and to continue predicting well on data it doesn't know. This means that it has learned well and hasn't learned by rote. But it's a little more complicated than that. In other words, in terms of data workflow, what I've shown you here is the training of the model at image level. So we split it into 3 test sets. On the other hand, what you deliver in production is an API that receives PDFs. As a result, you'll also have to set aside, and that's where you'll all get trapped, an integration data validation set. So PDFs, not images, but PDFs that have never been used by the drive. And this will enable you to validate that the predictions you make on these PDFs that have never been used to train the AI are the same on a training environment before deployment in production. And then you'll also be able to test in production. And you'll be able to validate that your production works. And that's really important. Remember, the grail of MLOps is to automate all this. In other words, when you have new data or feature changes, you'll need to change the code. When a pool requests a code modification, a single manual action, you'll be able to retrain and re-release into production. And if you can do that, you've reached the holy grail of MLOps. Thank you and see you soon for more videos.